Okay, Chapter 19, Balanced Scorecard, Quality and Time. And this presentation focuses on the 4 cost categories. These are all the objectives in this chapter, but we're going to really focus on 19.1, and then a little bit on financial and non-financial measures. You have access to the whole PowerPoint that you can use to help you with the reading, okay? But it's pretty straightforward stuff, and I actually think you've seen most of it before. Now we've got 4 different perspectives that we look at, and one is the customer perspective. Non-financial measures include, market research on customer preferences, market share, percentage of highly satisfied customers, number of defective units shipped to customers as a percentage of total units shipped. That's actually a tricky one. All right, that would be reflected on your, that would be a customer perspective. It's easy to look at it as an internal process perspective, Number of customer complaints, percentage of products that fail soon after delivery, average delivery delays, average delivery rate, or on-time delivery rate. So these are all customer perspectives, and make sure you're comfortable with these, Internal business perspective, they identify 3 techniques that are useful for identifying and analyzing quality problems. Control charts, Pareto diagrams, and cause and effect diagrams. Control charts are statistics. Statistical quality control is a means of distinguishing between random and non-random variations in processes. And random variations occur when maybe you've got a fluctuation in the speed of equipment or because of electrical problems, But non-random variations occur when defective products are produced because of systemic problems. This is something that you can fix. The random ones you really can't. There are a series of successive observations of a particular step, a procedure, or an operation, and each observation is plotted relative to specified ranges that represent the limits within which observations are expected to fall. And here's a real nice example of the daily defect rate, and you can see these are all random. This is random, but it's got something weird happening in here, like toward the end of when you get to 10 days. And this is product line C. You've got a definite a process that would not prompt investigation, but maybe would be misleading. Look at the trend here in these last 8 observations. There's a clear and unfavorable pattern that that under the guidelines indicates something's happening that deserves investigation. So maybe you've got a tool that isn't working or a machine that isn't quite working yet. So this is a good way to identify that kind of problem. Pareto diagrams indicate how frequently each type of defect occurs, ordered from the most frequent to the least frequent, and observations outside control limits serve as inputs for Pareto diagrams. So here's one, and this is a nice, really clear thing. Here the paper's not feeding properly. Here we've got fuzzy, unclear copies. This would be a big deal. Too light or too dark is a problem also. Well, they're all problems, but this shows you where the biggest problems are. The most frequently recurring and costly problems are identified and analyzed using these cause and effect diagrams. It shows you the potential cause of defects. They're called fishbone diagrams because it kind of looks like a fish. And the categories are human factors, methods and design factors, machine-related, and materials and component factors. So this is it. Here are our categories, like human, methods design, machine-related, and materials. And under human, the factors would include poor training, a new operator, inadequate supervision. Methods and design factors, flawed design, incorrect manufacturing sequence. So this is exhibit 19.5 in your text. It's a good exhibit, It's got good information in it. And Six Sigma is the ultimate goal of quality programs, and that means that the process is so well understood and tightly controlled that the mean defect rate and the standard deviation are both very small. Okay, so let's keep looking here. I wanted to get to the other categories here. These are some of the non-financial measures of internal business process quality. Percentage of defect products manufactured. Percentage of rework products. Number of different types of defects analyzed using these all those analysis methods that we just talked about. Number of design and process changes made to improve design quality or reduce the cost of quality. And notice that none of these products have left the shop yet, right? Okay, so they're not customer issues, they're internal business process quality problems. And then learning and growth. We've got experience and qualifications of design engineers, employee training, employee turnover, employee empowerment, and satisfaction. These are all characteristics of learning and growth. So the structure of the balanced scorecard perspectives can be used to summarize how the financial and non-financial measures of time relate to one another, reduce delays, increase the output of bottleneck operations. So financial measures are revenue gains or increases from fewer delays, carrying cost of inventory. Customer measures would include customer response time, on-time performance. Internal business process measures, average manufacturing time for key products, manufacturing cycle time, efficiency for key processes, defective units produced at bottleneck operations, average reduction in setup time and processing time at bottleneck operations. Okay? And finally, learning and growth measures, employee satisfaction, number of employees trained in managing bottleneck operations. And managers use both financial and non-financial measures to manage the performance of their firms along the time dimension.